NGC 1055 slices across Cetus like a blade of light, a spiral galaxy presented perfectly edge-on so that its entire architecture, bulge, disk, dust, and halo, collapses into a luminous line. In this sideways view the central hub swells gently while a dark, braided lane of interstellar dust carves through it, revealing where cold molecular clouds are stacked along the midplane. The stellar razor is not a pencil-thin uniform stroke, it's corrugated and slightly arched, a subtle warp that betrays long-term gravitational tugging. Star-forming knots bead the disk like sparks along a wire, their blue clusters and pinkish H2 regions peeking above and below the shadowed seam where newborn stars are clearing cavities in the gas. The Cetus scimitar lives in company. It shares space with the famed Messier 77 and several lesser companions, a loose association where tides are strong enough to wrinkle disks but not violent enough to shred them. That mild harassment explains the warp, the outer rings of gas are torqued out of the midplane, and the dust lane no longer lies perfectly straight. In radio wavelengths the luminous night shows an extended reservoir of neutral hydrogen that flares and bends at large radii. In the infrared it glows with warm dust heated by ongoing starbirth. Carbon monoxide measurements trace dense molecular clouds packed in the inner disk, the raw fuel from which the next stellar generations ignite. Optical spectra of the nucleus hint at a modest, low-level engine, more ember than furnace, while the disk does the real astrophysical heavy lifting, converting gas into stars at a steady clip. Because it is oriented edge-on, the island universe becomes a laboratory for vertical structure. Feedback from supernovae and hot stellar winds punches chimneys through the disk, lofting dust and ionized gas several hundred parsecs above the plane. Gravity and shear then comb those materials into filaments that rejoin the carousel of rotation. The result is a layered system, a thin, high-contrast midplane, a puffier thick disk of older stars, and a faint, boxy halo that swells on both sides like a soft aura. Deep images reveal wisps and spurs in that halo, possible relics of a swallowed dwarf, evidence that minor mergers have salted the outskirts with streams that gradually phase mix into smooth light. In its rotation curve, the galactic blade carries another quiet signature: velocities stay high far from the center, the classic imprint of an extended dark matter halo that outweighs the luminous disk and keeps the outskirts bound. Seen through small telescopes, the sidereal scimitar offers a stark geometry lesson, a bright spindle bisected by shadow, often framed in the same field as face-on M77, a striking juxtaposition of perspective. Larger apertures and long exposures add texture, scalloped dust, mottled star-forming knots dotted along the edge, and a gentle, asymmetric lifting of the outer disk. Narrowband imaging isolates hydrogen emission that traces where massive stars are carving bubbles, while mid-infrared views outline the polycyclic aromatic hydrocarbons that cling to dense cloud surfaces. In the radio, a flared skirt of HI wraps beyond the starlight, mapping regions where the disk is still gathering and cooling gas from its environment. The luminous saber offers a living chronicle of spiral disk ecology. Gas flows inward under the Baran spiral potential, piles up near resonances, and spawns clusters in a stop-and-go rhythm. Some clusters stay close to their birthplaces, others shear into feathery spurs. Supernovae seed metals into the interstellar medium, thickening the dust that later aids cooling for the next round of collapse. Over hundreds of millions of years, gentle tides from the group environment torque the outskirts, creating the graceful warp that gives the whole galaxy a slightly tilted, dynamic poise. Even the quiet nucleus fits the narrative, a central black hole likely dozes beneath a diet of trickling gas, its influence felt more in dynamics than in dazzling light. Historically, the Cetus razor has led astronomers step by step from simple sketches to multi-wavelength mosaics. Early observers noted only a dim, elongated smear, better optics split the bright core and the dark lane, photography exposed the warp, digital sensors uncovered off-plane filaments and a diffuse envelope. Today, integral field spectrographs can map how stars and gas stream past one another across the entire blade at once, while millimeter interferometers weigh the coldest clouds where stars are still only probabilities. Each new band adds a chapter to the same story, a mature spiral evolving not by cataclysm but by continuous negotiation, between gravity and pressure, inflow and feedback, solitude and companionship. What ultimately makes the edge-on spindle irresistible is the way it compresses cosmic processes into an elegant, single-stroke silhouette. Rotation, turbulence, star formation, chemical enrichment, halo growth, tidal stirring, everything is there, stacked along our line of sight like pages pressed together. The beauty is not just aesthetic, it's diagnostic. By watching how light is absorbed and re-emitted along that dark median line, astronomers can measure dust content, infer the scale height of the interstellar medium, and track how energy leaks from the disk into the surrounding halo. By reading the gentle arch of the outskirts, they can reconstruct the galaxy's recent gravitational history and estimate how often it has traded momentum with its neighbors. The stellar knife is therefore both artwork and instrument, a gleaming edge that cuts across the night and a cross-section that lays bare the anatomy of a spiral. In its glow we see the Milky Way's kinship to other disks, in its shadow we see the scaffolding of gravity that holds them all together. The longer you look, the more the straight line bends into a timeline, gas condensing, stars kindling, metals building, halos swelling, and the more that quiet warp starts to feel like a signature, a graceful underline beneath a continuing, galactic sentence. Kinematics turn the celestial cutlass into a living diagram of gravity. Along the midplane, stars and gas whip past at nearly constant speed far beyond the bright center, the telltale signature that mass continues invisibly into the outskirts. Edge-on geometry lets dust act like ink on a moving conveyor belt. By measuring how strongly different colors are dimmed across the dark seam, astronomers recover not just how fast the disk rotates but how thick the star-forming layer is and how turbulence swells with height. The thin disk hides a thicker, older component that carries longer-lived, redder stars. Above that, faint plumes of diffuse ionized gas glow where supernovae and hot winds have pressed energy into the halo. Each layer has its own scale height and dispersion, and the razor-thin spindle is the sum, the bright, sharp script we read across the sky. Near the center, the silver lancet shows the boxy shoulders of a bar seen from the side, a clue that internal dynamics have buckled the inner disk over time. Bars torque gas inward, piling it up in a ring where star formation intensifies. Some of that gas feeds the quietly dozing black hole, some cycles outward again in fountains after clustered supernovae. The pattern churns in slow motion, inflow along the bar, ignition near resonances, feedback that puffs material above the plane, then cooling and rainback that recedes the next spiral pass. Because the whole apparatus is inclined edge-on, even subtle asymmetries become legible, one side of the dust lane a shade higher than the other, one wing of the warp a bit more arched, small offsets that betray the push and pull of companions in the surrounding group. Chemical fingerprints deepen the story written on the luminous knife. Young clusters near the inner disk carry heavier elements forged by prior generations, while the outskirts tend to be more pristine, a gentle radial gradient that records how metals diffuse and how fresh gas trickles in. Supernovae salt the interstellar medium with oxygen, magnesium, iron. Those atoms lock into dust grains that both cool clouds and veil starlight, making the galaxy's colors a moving ledger of enrichment and obscuration. In the mid-infrared, complex carbon molecules outline the skin of molecular clouds. In the millimeter, cold carbon monoxide maps the densest star-forming reservoirs. Put together, the spectrum from ultraviolet to radio reads like a timeline of energy, massive stars blazing hot and brief, older stars warming dust, gas lines whispering about temperature and density where the next suns are still gestating. The cosmic yataghan is also a showcase for bending waves and ripples. Disks are not rigid plates, they are elastic, self-gravitating media, and a passing satellite can set them ringing for hundreds of millions of years. The warp in the edge-on wafer is that slow note made visible, a broad, low-frequency oscillation in which the outer rings precess in the dark halo's pull. Closer in, smaller amplitude corrugations ride the dust lane like scallops, vertical waves driven by spiral arms, bars, or ancient encounters. These standing patterns thicken the gas layer, modulate star formation, and seed off-plane filaments that look like stray brushstrokes above the midline. Magnetic fields and cosmic rays lace the blade's atmosphere. Along the disk, ordered fields thread the spiral pattern, above it, turbulence and outflows tangle lines into arches that guide charged particles into the halo. Radio continuum maps reveal a soft, extended glow cupping the wafer on both sides, evidence that high-energy electrons leak upward along magnetic scaffolding. In that glow, the galaxy ventilates, hot gas vents through superbubbles, cools, and rains back, a galactic weather cycle that links the thin, starry sheet to the dim halo that carries the memory of mergers and the promise of future accretion. Even the dark matter makes its presence felt through shape, not shine. To keep a disk this wide and this fast from unraveling, the enclosing halo must extend well beyond the starlight and remain roughly spherical. The exact degree of flattening can be teased out by how the warp precesses and how the outer gas flares. The bright edge thus becomes an interferometer of gravity, comparing the pull of visible mass to the deeper well that light cannot touch. When the rotation stays high at the edge while the surface brightness falls, the verdict is clear: most of the mass is not in stars or gas, yet it choreographs every curve of the spindle. The environment writes marginalia in the margins. The face-on neighbor in the same patch of sky offers tides without outright disruption, a regime that stirs rather than shreds. Deep exposures reveal faint streams and shells in the outskirts of the galactic scimitar, the archaeological remnants of small companions torn down to their stars. Those fossils add up, each ripple, each plume, each extraplanar knot is a receipt for a minor merger, and the smooth halo is what remains when time has mixed the debris into a diffuse envelope. In that sense, the halo is a ledger of patience, holding the long memory while the thin disk flashes with short-lived, high-contrast scenes. For observers, the silver blade reward strategy. A modest telescope shows a bright needle with a cut of shadow, a darker sky and longer exposure coax out the lifted ends of the warp and the faint aureole that swells around the midplane. Narrowband filters isolate star-forming knots, near-infrared views pierce the dust to expose the rounded heart, deep broadband stacks uncover the outer gas starlight dialogue where the disk hands off to halo. Frame the edge-on saber alongside its face-on neighbor and perspective itself becomes the teacher, one galaxy a line, the other a pinwheel, both telling the same physics with different handwriting. As a laboratory, the luminous dagger is unusually complete. It shows how bars redistribute angular momentum, how spirals gather gas, how feedback ventilates disks, how metals accumulate, how dark matter sets the stage, and how a group environment edits morphology with a light touch. It demonstrates why edge-on spirals are not just beautiful silhouettes but diagnostic cross-sections. The very geometry that hides the arms enhances the vertical structures that theories must match. Every new instrument adds resolution to that test, finer kinematics in the bulge, colder clouds in the inner ring, softer glows in the halo, yet the central impression remains constant, a single, gleaming stroke that condenses a galaxy's ecosystem into one precise line. And still the blade writes. Star-forming beads migrate, supernovae spark and fade, dust lanes kink and relax, bending waves march slowly outward. Over cosmic seasons the warp may settle, a fresh satellite may ruffle the outskirts, the bar may strengthen or weaken as gas flows ebb and surge. The edge-on cutlass is not a frozen emblem, it's a sentence mid-utterance, grammar set by gravity, punctuation added by feedback, meaning revised by encounters. To watch it is to read change as form, time as structure, and to sense, beneath the straight seam of darkness, the ceaseless negotiation by which a spiral galaxy stays itself. The starlit rapier is generous to anyone who watches it across many wavelengths because each band extracts a different layer of its anatomy without breaking the spell of that single, gleaming line. In the ultraviolet, strings of hot, short-lived stars beat along the midplane like sparks racing down a fuse. In the optical, the dust seam becomes an X-ray of the disk skeleton. In the near-infrared, older giants swell the central glow into a calm ember that refuses to flicker with extinction. Slide to the mid-infrared and the skin of molecular clouds lights up in aromatic carbon, a soft outline of where gas is dense enough to think about collapsing. At millimeter wavelengths the clouds themselves resolve into lanes and knots, cold reservoirs that mark tomorrow's constellations in blueprint. In the radio continuum a low, diffuse halo cups the wafer on both sides, the fingerprint of cosmic rays and ordered magnetic fields that reach far beyond the starlight, proving that the light slicer breathes through pores you cannot see in optical images. Time can be read along the scimitar's height. Close to the midplane, thin and cold gas obeys the spiral's traffic laws, shearing into ribbons and shocking into stars. A few hundred parsecs up, turbulence fattens the layer and the population reddens, evidence of kinematic heating by bars, spirals, and long-ago nudges from neighbors. Higher still, a dim spheroid of ancient stars and wayward clusters floats like frost above a river, fossils of the system's first assemblies. Planetary nebulae and globulars wandering in that soft envelope act as discrete test masses, their motion sketching the depth of the invisible well that holds everything together. Even the dust changes character with altitude, grain sizes skew smaller off the plane, scattering blue light more readily while the midplane hoards the heavy, sooty particulates forged in the last rounds of massive star deaths. The Cetus blade writes chemistry as gradients rather than proclamations. Metals slope gently downward from the inner disk to the outskirts, a record of how star formation has been most efficient where gas piles up under the combined torque of bar and arms, and less insistent where the rotation curve flattens and the clock runs slower. Yet the edge is not barren, it carries patchy, low-contrast regions where inflowing gas, cooler and more pristine, dilutes the mix and reprimes the pump. That interplay, enrichment from within, refreshment from without, keeps the luminous knife poised between saturation and starvation, never quite quenching, never quite exploding into a starburst, adjusting its cadence to the slow choreography of tides in its small group. Geometry turns the galactic foil into an instrument. Against the smooth bulge light, the dust lane functions like a laboratory slit, and spectra taken across it resolve the vertical temperature, density, and velocity structure of the interstellar medium as if the disk were a stacked series of translucent films. You can watch pressure support rise with height, track how turbulence decays, and measure how ionized gas lingers longer above the plane than the neutral phase. In the inner few kiloparsecs, subtle box and peanut shoulders betray a bar seen side-on, a buckled heart that has lifted stars onto banana-shaped orbits and thickened the central layers without erasing the razor's profile. That same bar whispers to the nucleus, steaming a trickle of gas inward where it smolders rather than flares, a steady diet that maintains a faint, hard glint in X-rays and a compact radio prickle without ever claiming center stage. The stellar saber is restless at its rim. There the HI layer flares and lifts, a visible compromise between centrifugal ambition and the dark halo's persuasion. Weak bending waves travel through those outskirts like swells under a sheet of ice, launched by old encounters and damped only slowly by self-gravity and the viscosity of random motions. Star formation in that regime is a marginal enterprise, igniting where spiral compression or tidal wrinkles briefly push the gas above the threshold. The result is a stippled border of faint knots that come and go on 100-million-year timescales, adding a grain to the luminosity while the mass budget is decided in colder, quieter negotiations. Feedback gives the sidereal cutlass weather. Clustered supernovae carve superbubbles that rise, stall, and vent, building chimneys whose caps glow in soft recombination light and whose shafts are lined by magnetic filaments. Along those guides, electrons surf outward to make the radio halo, ash from the explosions, fresh metals and tiny grains, snowballs into the circulation, cooling, sinking, and thickening the midplane dust seam that first hooked your eye. It is a galactic monsoon with no single season. Somewhere along the blade the rain is always falling back, somewhere else the boil is rising, and over an orbital period the ledger balances closely enough that the disk's silhouette never loses its edge. Distance and scale become more than numbers when the edge-on spindle is used as a rung on the cosmic ladder. The crowded midplane is unkind to many indicators, but the outskirts and halo are kind. There, resolved red giant stars approach the limit of detectability and can be harvested for clean distance estimates, while the diffuse light fluctuations of the thickened inner regions add a cross-check in the near-infrared. Those measures, combined with the group geometry, weave the galaxy into a three-dimensional map where tidal responsibilities and historical suspects can be assigned, which neighbor lifted the warp, which flyby salted the halo with streams, which shared filament still ferries cool gas into the system's outskirts today. Even the cadence of starbirth along the luminous dagger has a melody. Spiral resonances set the tempo, the bar modulates the bridge, shear and feedback write syncopation into the beat, so that clusters form in bursts, drift apart, fade in ultraviolet, and glow on in the near-infrared while the next measure starts closer in. You can read the score by stacking tracers: ionized gas for the fresh notes, ultraviolet for the adolescent phrases, infrared for the sustained chords, radio for the lingering overtones. Together they resolve the disc into polyrhythms, all contained within that unbroken line that first looked so simple. What endures, after the catalog numbers and spectral classifications and rotation curves are set aside, is the way that galactic rapier turns complexity into a silhouette. A single stroke, and yet inside it, migration and mixing, ringing and warping, breathing and raining, feeding and fasting, remembering and forgetting. Watch long enough and you can feel the curve of the warp inch forward, the dust seam kink and relax, the halo's faint veil thicken by imperceptible degrees as new stars die and return their atoms to the cycle. The weapon's edge is not for cutting so much as for writing, one continuous, luminous sentence the universe has been composing for billions of years, with the next clause already forming in the cool, dark ink of molecular clouds tucked just beneath the shadowed line. Beyond its bright spine, the luminous rapier hides an intricate migration map. Stars born in the crowded inner lanes drift outward over billions of years, their orbits slowly heated by spiral arms, bars, and the soft jostling of passing clumps. That drift smears metallicity into a shallow gradient, so the outer disk is not simply primitive but salted with elders that carry the chemistry of the core. Some travelers overshoot the plane entirely, joining the thicker, puff component that wraps the blade like a faint scabbard. There, kinematics loosen, colors warm, and the memory of past perturbations is written as extra dispersion rather than sharp structure. The Cetus saber invites you to read dust as engineering. Grain sizes segregate with environment, big, sooty particles settle toward the midline and carve the high-contrast lane, finer grains ride turbulence higher and scatter blue light into a soft, powdery veil. When clusters turn on, they bleach local cavities, pushing dust into arcs whose curvature betrays pressure gradients and magnetic tension. Aromatic hydrocarbons sketch glowing outlines on the cloud surfaces, while colder cores stay invisible until millimeter eyes reveal them as tight, high-density knots. Even the lane's slight kink is a ledger entry, shear and feedback are negotiating, and the sag marks where gravity wins. The stellar symmeter is honest about thresholds. Gas at the rim hovers near the line between calm and collapse, and star formation there lights up in intermittent stipples, as if the galaxy were testing each parcel for readiness. A passing compression from a spiral wave or a bending ripple nudges patches over the edge, a flare of ultraviolet follows, feedback quenches the patch again, and the cycle resets. Closer in, where surface density is higher and shear is gentler, the cadence smooths into longer phrases, complexes, associations, and fossilized superbubbles that layer like tree rings across the midplane. Viewed as a machine for moving angular momentum, the edge-on foil is all levers and flywheels. The bar torques gas inward, the outer arms carry angular momentum away, the halo absorbs the bookkeeping errors so the thin disk can keep time. Resonances, inner, outer, corotation, act like gears that couple flows, pile gas into rings, and set preferred radii for ignition. Because the system is tilted exactly right, those gears leave shadows and shoulders in the light, a set of subtle cues that make dynamical modeling less guesswork and more measurement. In its halo, the silver lancet keeps quiet company with relics. Off-plane globular clusters drift through like lanterns in fog, each one a tracer of mass beyond the light. Planetary nebulae in the thick disk add a pointiest record of older populations, their expansion lines splitting neatly around the systemic speed to reveal the depth of the potential well. Faint shells flare in deep exposures, edges of phase-mixed streams from dwarfs that surrender to tides. Taken together they tell you the outskirts have been fed by patient sips rather than violent gulps. The light slicer is a natural testbed for the interplay of order and turbulence. Along the midplane, rotation herds the gas into lanes, aligning filaments with shear, perpendicular to it, Feedback roughens the texture, lofting froth that later settles in a slow snow. Magnetic fields thread both regimes, tightening where gas is compressed and arching where fountains break through, guiding cosmic rays into a broad radial cocoon. That cocoon is not merely a byproduct, it moderates how heat leaks from the star-forming layer, cushioning shocks and helping the disk avoid catastrophic swings between burst and famine. As a rung on distance ladders, the galactic rapier rewards patience. Surface brightness fluctuations in the bulge, the tip of the red giant branch in the outskirts, and the group geometry with its neighbors cross-check one another until uncertainties narrow to a clean anchor. Once placed, the spindle becomes a calibrator in its own right, a point on the Tully-Fisher relation, a sanity check for stellar population models that must reproduce the color and thickness of both thin and thick disks, a playground where vertical equilibrium can be balanced against measured turbulence without hiding behind face-on ambiguity. Simulations find their mirror in the sidereal cutlass. When an n-body disk soaks up a minor merger, its outer rings ring. When gas cools in a live halo, warps flare and precess. When bars buckle, the heart grows boxy and the lane tilts a hair. Run the model forward and backward, trim the satellite's mass, change the halo's shape, dial the gas fraction, and the imprint on the razor's silhouette shifts in predictable ways. Matching that silhouette is how theory earns the right to talk about unseen histories. For human eyes and backyard mirrors, the edge-on spindle remains wonderfully democratic. Under modest skies it is a bright needle with a smoky fissure, a geometry lesson that never gets old. Under darker skies, the ends lift and the halo appears like breath on glass. A sensitive sensor records a fine, granular texture along the dust lane, tiny irregularities that are not noise at all but the tangible grain of star formation arranged by shear. Frame it with its face-on neighbor and you learn more about perspective in one field than a semester of drawings could teach. And through it all the luminous dagger keeps writing. Spiral traffic thickens, clusters kindle, chimneys vent, metals seed, rain falls back, the rim flexes, the bar whispers to the core, the halo listens. Nothing in the scene is wasted, even the darkness along the seam is information, telling you how much dust, how tall the gas, how fast the midplane turns. Stand back and the galaxy is a single stroke. Lean in and it's a city of processes, each with its own clock, all agreeing just enough to hold a straight line against the night. The light slicer also carries a biography written in age. Its thin disk is youthful and restless, patterning itself into lanes where gas cools, self-gravitates, and collapses. Its thick disk is older and calmer, a memory foam of orbits puffed up by ancient perturbations. Inside-out growth leaves telltale signatures, younger clusters concentrate toward the bright inner blade, while the outskirts host sparser, lower metallicity associations that speak of slower clocks and fresh infall. That inside-out pattern is not cosmetic, it changes how starlight is absorbed and re-emitted, how dust grains evolve, and how the galaxy regulates its own tempo without tipping into famine or frenzy. In the midplane of the stellar knife, stability walks a tightrope. Gas wants to collapse under gravity, shear tries to tear condensations apart, pressure and turbulence steady the rope. Where these forces balance near a critical threshold, filaments beat up into cloud complexes. The rotation field sets the spacing of those beads, while spiral compression and bar torque set their pacing. Once ignition starts, feedback from massive stars carves cavities, launches shells, and briefly raises the local stability again, an elegant, self-limiting cycle that keeps the blade forming stars steadily rather than in wild bursts. Vertical structure turns the sidereal cutlass into a physics classroom. The scale height of the cold layer shrinks where gravity is strong and broadens where turbulence wins. Above it, a warm ionized skin glows faintly as photons leak from H2 regions and supernovae heat the gas. Higher still, a dim fog of old stars and fossil streams thickens into a rounded envelope. Measure how these layers change with radius and you learn the hidden geometry of the mass, where the dark halo dominates, where the disk's own gravity is king, and how the warp precesses under a potential that is not perfectly flat. Magnetism and cosmic rays give the galactic rapier an invisible architecture. Compression along spiral lanes orders the field, fountains bend it into arches that guide relativistic particles upward. The result is a radial cocoon that cups the disk, smooth where turbulence is gentle and striated where chimneys break through. Faraday rotation maps act like weather vanes in this flow, revealing where the field flips and where thermal electrons pool. Those same fields slow heat transport, cushion shocks, and help the interstellar medium avoid extremes, another quiet thermostat built into the silhouette. Far from the bright seam, the silver lancet negotiates with its environment. Neutral hydrogen flares and lifts, thin star-forming knots appear and fade at the rim, and faint plumes hint at past accretions that never quite shattered the disk. Lopsidedness creeps in where a one-armed, m=1, mode lingers, a subtle asymmetry that can persist for gigayears after a modest tidal nudge. The warp itself is a ledger of misalignment, gas settling along a slightly tilted plane, outer rings precessing slowly under the pull of a rounder halo than the disk would prefer. In the core, the Cetus blade shows the restrained signatures of secular evolution. A side-on bar thickens into box and peanut shoulders, lifting stars onto banana orbits and piling gas into a ring where the cadence of star formation quickens. Some inflow threads the last parsecs to feed the central black hole in a low, simmering mode, some is kicked back in fountains that seed the thick disk with fresh metals. Over long times, this traffic redistributes angular momentum, inner regions shed it and sink, outer regions absorb it and spread, while the halo quietly keeps the book so the disk can keep its line. Chemistry, too, is layered into the luminous dagger. Heavy elements track the long memory of star formation, dust carries them into grains that catalyze new molecules, and radiation fields sculpt both with depth. Near the midplane, big, sooty grains dominate and carve that high-contrast lane. Higher up, smaller, more fragile particles survive and scatter blue light into a gentle veil. Polycyclic aromatics sketch the skins of clouds, carbon monoxide marks their cold hearts, diffuse atomic gas tags the waiting room where tomorrow's clouds are assembled by shear and drift. Transients pepper the blade with punctuation. Quark-elapsed supernovae flash and fade in OB associations, X-ray binaries wink from the thick disk, classical novae briefly write their signatures before folding back into anonymity. Each event is small, but together they churn the gas, enrich the dust, and loft material into the halo, sustaining the fountain that connects the thin, bright script to the dim, archival envelope above and below. For modelers, the edge-on foil is merciless and fair. Change the halo's shape and the warp's precession shifts, soften the feedback and the gas layer collapses too thin, weaken the bar and the boxy heart relaxes. Only specific combinations reproduce the observed thickness, the gentle asymmetry, the placement of star-forming beads, and the breadth of the radial cocoon. Matching that silhouette across wavelengths is not an aesthetic exercise, it is a multivariate constraint, the kind that forces theory to choose. And for human eyes, the light slicer keeps offering new lessons with the simplest of forms. On a first look it is a bright line and a dark seam, on a second it is a cross-section of galaxy ecology, on a patient night it becomes a living diagram, matter cooling, gravity gathering, stars kindling, feedback breathing, halos remembering. The more you attend, the more that straight stroke feels like a time exposure of balance itself, a system held together by counterweights and returns, by push and pull, by 1,000 local transactions that sum to a single, unwavering edge against the dark. At human scales that a celestial razor looks serene, but inside it runs on traffic rules written by gravity. Gas streams along lanes set by resonances, slows where orbits crowd, and stacks into rings that quietly raise the local pressure until clouds flip from translucent to opaque. The initial mass function does its usual work, many small stars, few giants, yet the ratio drifts with environment, edging top heavier in the densest pockets near the inner blade where turbulence and temperature are highest. Clusters that survive their first few tens of millions of years settle into the disk's rhythm, shear stretching them into elongated associations that fade into the background light while their most massive members seed the next round of metals. Age leaves its mark as a U-shaped pattern along the radius, old in the bulge bar heart, younger across the main star-forming lanes, older again in the far outskirts where the clock ticks slowly and only occasionally leaps forward. Vertical structure tells the same story in a different accent. The relation between age and velocity dispersion tilts upward, older stars bounce higher above the plane, so the thick, warm sheath around the wafer is less a separate component than a fossil of long arithmetic, spirals heating orbits, bars buckling, and minor encounters adding a little random motion each time. Look closely at the dust and you can read the radiative transfer problem written in real time. The extinction curve along the midplane steepens in patches where small grains dominate and flattens where larger, sootier particles settle. Scattered light fills narrow aureoles above the seam, proof that some photons find detours even where the lane looks opaque. Models that fit the colors must fit the geometry too, because a straight shadow with a gentle arch is a constraint, the scale height of gas, the clumping factor of clouds, and the relative weighting of thin versus thick disks all leave fingerprints on that silhouette. At the rim, neutral hydrogen puffs into a flared skirt and quietly negotiates with gravity. There, star formation is a threshold game, surface density flickers around critical, shear tries to tear condensations apart, and spiral or tidal compressions arrive as occasional nudges. When a patch tips over, a cluster lights, ultraviolet bleaches a cavity, and the local tumor Q rises until cooling and drift reset the conditions. Over hundreds of millions of years the ledger balances, no runaway burst, no permanent quench, just a long average that keeps the luminosity smooth. The halo carries the archive. Globular clusters wander like mile markers through a potential deeper than the light implies. Planetary nebulae and horizontal branch stars sketch velocity ellipsoids that widen with height. Faint arcs and shells hint at swallows of small companions whose stars are still phasing into anonymity. Even where streams have dissolved into smoothness, chemistry remembers. Alpha-enhanced, metal-poor populations float higher, while the midplane hoards younger, iron-richer stars whose supernovae came from slower clocks. Magnetism threads the whole structure. Ordered fields align with the spiral pattern in the dense sheet, then arch into the atmosphere where chimneys vent. Along those arches, relativistic electrons ride outward to paint a soft radio cocoon that outlives its stellar parents. Faraday rotation angles flip with height and radius, telegraphing where the field reverses and where thermal electrons pool. The net effect is a quiet thermostat, shocks cushion, heat leaks more slowly, and the disk avoids the violent swings that simpler recipes would predict. The central engine stays modest but meaningful. A side-on bar builds box and peanut shoulders, driving gas toward an inner ring where star formation runs a faster tempo. Some fraction threads inward to the black hole, which answers with a hard, compact glow and occasional wisps that never quite dominate the scene. Over secular times this traffic moves angular momentum like money, the interior pays down, the outskirts save, and the dark halo keeps the account so the razor's outline keeps its line. Beyond immediate neighbors, the larger web still matters. Cool inflow along misaligned filaments can feed the outer gas and keep the warp fresh. A passing dwarf can plant a long-lived lopsided mode that shows up not as a scar but as a gentle asymmetry in brightness and thickness. Simulations that reproduce the edge's slight lift and the lane's mild kink tend to share the same ingredients: a live halo, a buckled bar, a few minor mergers, steady but not extravagant accretion, and feedback tuned to ventilate without blowing the doors off. For observers the geometry is a gift. The same edge-on view that hides spiral arms turns vertical physics into something you can measure directly: scale heights, flaring, corrugations, fountains, halos. Spectra across the seam read out temperature and turbulence with height. Integral field maps unwrap rotation and shear without the ambiguity of a face-on projection. Distance anchors follow, whether from red giant tips in the outskirts or from surface brightness fluctuations closer in, and once placed on a clean rung the spindle becomes a calibration point, its rotation and luminosity speaking the language of Tully Fisher with no translator. Project it into the future and nothing abrupt happens, which is its own kind of drama. The bar may wax and wane, the warp may precess and settle, the rim may keep testing patches for readiness while the halo slowly fattens on the interest of many small accretions. If a heavier neighbor finally wanders too close, the razor will ring and its outline will change. Short of that, it will keep writing its single, legible sentence: gas to clouds, clouds to stars, stars to metals and dust, dust back to clouds, all under the even pressure of a dark halo that never shows and never sleeps. And that is the quiet appeal of the Cetus spindle, not spectacle, but balance, an edge that holds because everything inside it agrees just enough, for just long enough, to keep the line straight. The celestial scalpel is also a map you can hear with spectra. Slice long slits across the midline and the position, velocity diagram blooms, bright ridges for the rotating disk, faint wings for extraplanar gas, tiny kinks where shocks and streaming along spiral lanes steal or donate a little speed. Envelope tracing methods pull out the terminal velocities, integral field units unwrap the twist of the inner bar, and once beam smearing is tamed the rotation curve holds steady well past the bright spine, a quiet verdict on the reach of the unseen halo. Even the warp signs its name there, at large radii the ridges tilt, proof that the outer rings are precessing in a plane slightly misaligned with the inner blade. Starlight in the luminous filament carries layered memories. Integrated colors of the thin disk lean young and moderately metal-rich, the thick sheath above it runs older, alpha-enhanced, and dynamically warmer. In the outskirts, resolved red giant tips begin to flicker into detectability on deep frames, letting distance and metallicity be read star by star, while planetary nebulae mark older cohorts with tidy emission lines that stand out against the smooth continuum. String those tracers together and an inside-out growth story emerges. The bright inner edge writes fast, the far rim writes slowly, and migration smudges the ink between. Dust, the galaxy's calligrapher, sets the contrast of the light blade. A clumpy, stratified mix of grains turns radiative transfer into sculpture. Large, sooty particles huddle near the midplane and carve a crisp, dark seam. Finer grains ride turbulence higher and scatter a faint, bluish haze above the line. Where clusters turn on, cavities bloom, arcs and shells that curve with pressure gradients and magnetic tension, and the lane silhouette kinks by a hair. Models that reproduce the colors must match the geometry, the scale height of gas, the clumping of clouds, and the ratio of thin to thick disk are written in the exact sharpness of that shadow. At the heart of the edge-on saber, secular evolution speaks in low tones. A buckled bar thickens into box and peanut shoulders, lifting stars onto banana orbits and piling gas into a circumnuclear ring. Star formation there runs a quicker cadence, some gas threads inward to a quietly accreting black hole, which answers with a compact hardness rather than a blaze. Over long times this traffic moves angular momentum like currency, inner regions pay down, outer regions save, while the halo holds the ledger so the outline stays true. Farther out, the silver spindle negotiates with thresholds. The atomic layer flares, shear and low pressure conspire to keep clouds marginal, spiral compressions or gentle tidal wrinkles nudge patches across the line and brief star-forming stipples appear, fade, and leave behind only a grain in the surface brightness. Weak bending waves, launched by past flybys or misaligned infall, slide through the outskirts like swells under ice, thickening the gas and shifting where those stipples prefer to light. Magnetism gives the galactic rapier an invisible trellis. Ordered fields track the spiral pattern in the dense sheet, then arch into the atmosphere where fountains vent. Along those arches, cosmic ray electrons drift outward and paint a soft radio cocoon that outlives the massive stars that launched it. Faraday rotation angles flip with height and radius, betraying field reversals and thermal pools. The net effect is a quiet thermostat that damps shocks, slows heat leaks, and steadies the disk's mood between burst and famine. Kinematics with height turn the light slicer into a vertical lab. Velocity dispersion climbs from cold molecular lanes to warm ionized skins and then to the dim halo, where ancient stars and wayward clusters carry broad ellipsoids. Plot dispersion against age and the slope rises, older cohorts bounce higher, a fossil of orbit heating by spirals, bars, and many small encounters. Corrugations ride the dust lane, sub-kiloparsec ripples that likely mark vertical waves, adding texture you can measure in both light and line-of-sight speed. Environment adds the marginalia, A nearby face-on heavyweight stirs without shredding, keeping the warp fresh and seeding a mild lopsidedness that refuses to die on gigayear timescales. Faint shells and wisps in the halo are the long-exposure handwriting of minor mergers, receipts for small companions paid into the ledger of mass. Even where streams have phase mixed, chemistry remembers, alpha-rich, metal-poor stars floating higher than the younger, iron-richer cohorts that cling to the thin, bright script. As a rung on cosmic ladders, the Cetus blade rewards patience rather than flash. The red giant tip in the outskirts, surface brightness fluctuations in the thickened core, and the clean Tully-Fisher pairing of rotation and luminosity cross-check one another until uncertainties shrink. Once placed, the spindle itself calibrates models, its thickness pinches feedback and turbulence into a narrow range, its warp tests halo shape, its star-forming beads challenge recipes for thresholds and shear. Project the stellar knife forward and the drama remains balanced. The bar may wax and wane, bending waves may precess and fade, the rim will keep testing parcels for readiness while the halo gains mass one quiet sip at a time. Unless a true heavyweight blunders close, evolution will stay secular, gas to clouds, clouds to clusters, clusters to metals and dust, dust back to clouds, an ecosystem held in shape by gravity's grammar and moderated by feedback's punctuation. And that is the enduring magic of the edge-on silhouette, one unbroken line that manages, all at once, to be a cross-section, a chronicle, and a promise that the sentence is still being written. The edge-on quill also reveals how galaxies trade energy with their surroundings without losing their composure. Hot plasma from clustered supernovae rises in buoyant plumes, cools as it expands, and condenses into fine filaments that drift back toward the midplane. That fountain circulates metals into the atmosphere and returns them to the thin disk, slowly enriching the gas that will seed the next generation of stars. Because gravity, pressure, and magnetic tension share the load, the circulation rarely breaks symmetry, instead it ventilates the disk just enough to keep star formation self-regulated rather than explosive. In the Cetus needle, spiral traffic and secular drift build structure without erasing it. Gas streams along shocks at the bar's leading edges, piles into an inner ring where cloud collisions become frequent, and lights clusters in loose pearls that shear into elongated associations. Over hundreds of millions of years, churning and migration smear those associations into the smooth glow of the stellar background, but the dust remembers longer. Kinks, spurs, and scallops linger along the lane as raised reliefs of past ignition. The visual simplicity of a single dark seam hides the long bookkeeping of angular momentum exchanged between bar, arms, and halo. Seen as a laboratory of vertical physics, the luminous broadsword is unusually legible. Cold molecular gas hugs a razor-thin sheet, warmer atomic gas flares outward with radius, a faint, ionized skin floats above both, lit by stray photons and stirred by winds. Each layer has a distinct scale height and velocity dispersion, and the way those grow with radius tells you where the dark halo begins to dominate the restoring force. Even the warp is diagnostic, its gentle twist betrays a misalignment between the outer gas and the inner stellar disk, a clue that accretion and tide still whisper at the edges. The stellar saber keeps time with chemical clocks as well as with orbits. Heavy element abundances fall gradually from center to rim, but not monotonically. Patches of diluted gas at large radii mark recent infall, while migrated inner disk stars carry richer chemistry outward. Dust participates in the cycle as catalyst and historian. Big grains settle and carve contrast into the midplane, small grains ride turbulence higher and scatter a bluish veil, and aromatic molecules outline the cloud skins where ultraviolet has thinned but not erased the carbon chemistry. Read together, these tracers reconstruct how supply, demand, and recycling have coexisted without boom-and-bust extremes. The galactic rapier is also a stern examiner of theory. Make the feedback too weak and the gas collapses into an implausibly thin sheet, make it too strong and the disk puffs until the lane loses its bite. Mistune the halo's shape and the warp precesses at the wrong rate, soften the bar and the boxy heart disappears, overfeed the nucleus and the quiet X-ray/radio prickle becomes a glare. Matching the silhouette across wavelengths, its thickness, its mild lopsidedness, its radio cocoon, its flared outskirts, forces models into a narrow corridor where gravity's grammar and feedback's punctuation finally agree. In the outskirts of the silver spindle, thresholds rule. Surface density hovers near critical, shear is high, and bending waves slide through like swells under thin ice. Star formation there arrives as stipples, brief, low-contrast knots that appear where compression nudges clouds across the line and fade once feedback lifts the local stability again. Over a gigayear, those stipples add only a gentle grain to the luminosity profile, yet they keep the rim chemically alive and provide tracers for measuring how the disk exchanges momentum with the halo. For the halo of the light blade, archaeology never ends. Off-plane globular clusters carry long, slow orbits that probe a potential deeper than the starlight suggests. Planetary nebulae in the thickened component map older kinematics with tidy emission lines. Faint shells and wisps mark where small satellites were torn down and phase mixed into smoothness. Even when streams dissolve, abundance patterns persist, alpha-rich, metal-poor cohorts floating higher than iron-richer populations, preserving the memory of early, rapid star formation long after geometry has blurred. From an observational craft perspective, the celestial scalpel rewards discipline. High dynamic range imaging pulls faint aureoles and warp lifts without saturating the bulge. Integral field spectroscopy resolves rotation and shear across the seam. Millimeter interferometry weighs the cold reservoirs that blueprint tomorrow's stars. Polarization maps trace magnetic trellises that guide cosmic rays into the radio halo. Narrowband views isolate ionized chimneys feeding the circulation. Layer those maps and the single dark line becomes a stack of transparent films, each a different phase of the interstellar medium, each obeying the same overall potential. Project the Cetus blade forward and a pragmatic future emerges. Secular evolution continues, the bar may strengthen or relax, the inner ring will ebb and flow with supply, the warp will precess slowly under the halo's hand. Minor accretions will keep salting the outskirts, but unless a heavyweight intruder arrives, the disk will hold its edge. Steady star formation, patient recycling, gentle mixing, and a silhouette that changes only by degrees. That constancy is not stasis, it is balance sustained by many small negotiations. And that may be the quiet lesson of this Aegean universe. The luminous dagger is dramatic because it is disciplined, a single stroke that compresses the whole ecology of a spiral: cooling, collapse, ignition, enrichment, ventilation, accretion, into one readable line. The beauty serves the physics, and the physics sustains the beauty. Keep watching, and the straight seam will keep writing, one clause per orbit, in the cool ink of molecular clouds and the warm light of the stars they become. The Cetus rapier also carries a layered memory in its stellar motions that you can read like contour lines. Close to the plane, orbits are cool and flattened, nearly circular streams that keep the seam narrow and high contrast. A few hundred parsecs up, dispersions widen and orbits tilt, the signature of gradual heating by spiral waves, bar buckling, and countless small nudges from passing clumps. Still higher, the density profile bends into a softer slope, a transition where ancient debris and a puffy, kinematically warm component overtake the light from the razor-thin sheet. That break is not just geometry, it's a timestamp on how quickly the disk settled from its early, turbulent youth into the ordered rotation that now holds the edge. Inside the luminous blade, resonance structure organizes traffic with quiet authority. Corotation sets the drumbeat for the bar. Inner and outer Lindblad resonances act like gates that part gas into rings. Crowding of orbits near those gates thickens the dust and sets off a pearl string of H2 regions. Because we view the system edge-on, those pearls stack, turning three-dimensional spirals into a single, mottled ink line whose brightness subtly waves with radius. Even without seeing the arms directly, their cadence survives projection. A rise where lanes converge, a lull where shear thins the gas, a second rise at the outer resonance where compressions revive star formation in the rim. Chemistry writes footnotes along the stellar knife. Inflow brings slightly leaner gas to the outskirts, diluting heavy elements there. Migration ferries metal-richer stars outward from the inner disk, flattening what would otherwise be a steep gradient. Dust tracks these trades, big grains collect where supply and pressure are highest, carving the dark seam with crisp contrast. Smaller grains and aromatic molecules ride turbulence higher, painting a faint halo that blends with altitude. Photoelectric heating on those grains keeps the neutral medium warm enough to resist runaway collapse, while shielded cores in the densest knots slip under the threshold and quietly begin new clusters. The edge-on quill is equally instructive in the coldest phases. Molecular lanes hug the midplane with a scale height so small that even a modest kink becomes diagnostic. Shear is strong, feedback has punched a cavity, or a bending wave is passing through. Where lanes intersect projected bar orbits, cloud collisions rise, and the star-forming duty cycle shortens. After ignition, winds and supernovae vent up chimneys, stretch magnetic field lines into arches, and loft metals into the atmosphere. Cooling then stitches that material into thin filaments that drift back, fountain-driven accretion that quietly tops up the disk without a dramatic supply shock. Dark matter, though unseen, speaks through shape. To keep a disk this broad, fast, and thin from unraveling, the halo must be deep and comparatively round. Its exact flattening reveals itself in how the outer gas flares and how the warp precesses. Nudge the halo triaxial and the line of nodes twists too quickly, round it too much and the flare underperforms the observed lift. The galactic rapier, therefore, doubles as a gravimeter. Once the visible mass is booked, the residual pull that maintains high rotation at the edge and steadies the warp can only come from the shadowy envelope that cradles the light. In the halo of the silver spindle, archaeology proceeds one tracer at a time. Off-plane globular clusters carry long orbital baselines that probe the depth of the potential. Planetary nebulae outline older kinematics with clean emission lines, the colors of red giant stars in the outskirts, where crowding relents, encode both distance and metallicity. Faint shells and asymmetric veils betray bygone accretions that never shattered the disk but salted it with memory. Even after those streams phase mix into smoothness, abundance patterns persist, alpha-enhanced, metal-poor cohorts floating higher than younger, iron-richer stars that cling to the bright script below. As a living laboratory, the light blade tests feedback with a ruler, not a guess. Too little stirring and the gas layer collapses razor-thin, dust saturation deepens the seam, and star formation tips into unhealthy bursts. Too much and the lane loses bite, the midplane puffs, and the edge blurs. The observed thickness, the amplitude of corrugations, the breadth of the radio cocoon, and the measured rise of velocity dispersion with height together pin feedback to a narrow, self-regulated corridor, enough to ventilate, not enough to unthread the spine. Even timekeeping has multiple hands in the Cetus saber. Ultraviolet sketches fresh notes, hydrogen recombination lines hum a recent chorus, near-infrared sustains older chords, and radio continuum holds the overtones of cosmic rays long after massive stars have faded. Stack those clocks and the disk resolves into polyrhythms, quick phrases near the inner ring, steadier measures across the main lane, staccato stipples at the rim where thresholds rule. The harmony is secular, not explosive, an orchestra tuned by gravity and kept in time by the quiet metronome of the dark halo. Project that a celestial scalpel, across the next few billion years, and its drama remains one of poise. The bar will wax and wane, the box and peanut heart may sharpen, the warp will slowly precess, the rim will continue its threshold experiments, and the halo will thicken on the interest of many small accretions. Unless a heavyweight interloper barges in, the blade keeps its line, gas to clouds, clouds to clusters, clusters to metals and dust, dust back to clouds, one continuous sentence written edge-on across the night, legible from a backyard mirror and exacting enough to school the largest telescopes on how a spiral galaxy stays itself. The photonic stiletto also threads a quiet exchange with its circumgalactic sea. Beyond the bright seam, a diffuse, multiphase envelope waits, cool clumps adrift in a warmer bath, all of it suspended in a hotter, near-invisible medium. Outflows from clustered supernovae pepper this loft with metals and dust grains, radiative cooling beads that mixture into wisps that drift back down as precipitation. The cycle is not dramatic, but it is relentless, gentle inflow along filaments at the rim, fountains from the midplane, slow mixing in the halo, and a steady return that keeps the thin disk supplied without ever flooding it. Inside the starlit disk, cloud physics sets the local tempo. Turbulence shreds and stitches molecular gas on short clocks, gravity prunes the fragments that cross the density threshold, magnetic tension slows the collapse just enough to keep efficiency modest. The outcome is a fractal ledger, filaments, knots, and cores nested like sentences within paragraphs, where feedback edits the draft before it runs away. You can see the revisions written into the dust, crescent shells around newborn clusters, scalloped rims where winds have shaved a cavity, narrow pillars that point back toward the ignition sites like exclamation marks in silhouette. Kinematics turn the sidereal katana into a vertical chronometer. Cold lanes near the midline carry tight dispersions. A few hundred parsecs up, the warm component thickens and the velocity ellipsoid widens. Higher still, ancient stars and wayward clusters drift on slow, roomy orbits that ignore the thin disk's nervous rhythm. Plot dispersion against age and the curve rises smoothly, evidence that orbit heating has been cumulative rather than catastrophic, a sum of many small pushes from spirals, bars, and passing substructure. Even the light budget of the luminous blade is a balancing act you can solve. Young, hot stars pour energy into the ultraviolet, older populations supply the near-infrared backbone, dust harvests the short wavelengths and re-emits them in the mid- and far-infrared. Cosmic rays and magnetic fields hold a radio afterglow that outlives their massive parents. Close that energy ledger, input versus output, absorption versus re-emission, and the numbers force a self-consistent portrait of geometry, how thick the dust is, how clumpy the clouds are, how much starlight escapes above the seam and how much is folded back into warm grains. Resonances give that edge-on a pay its interior grammar. Gas streaming along the bar stalls into an inner ring, outside, pattern speed sketch lanes where orbits crowd and shocks sharpen. Farther out, the rim rides the edge of stability, igniting only when compression delivers a nudge. Between these provinces, migration works like a slow penumbra, smearing sharp chemical contrasts into gentle gradients as stars wander outward and inward over billions of years. The gradient never vanishes, it just softens, a record of supply and demand written in metals rather than ink. In the outskirts, the silver lancet practices restraint. Atomic gas flares as gravity weakens and the restoring force tilts from the disk to the halo, bending waves slide through like swells under winter ice, thickening the layer and shifting where patches cross the star formation threshold. The knots that appear are brief and low contrast, flickers rather than flares, yet they matter, keeping the rim chemically alive and seeding tracers that map how angular momentum trades hands between disk and halo. Halo archaeology around the light blade proceeds by lantern light. Globular clusters orbit as bright signposts in thin air, planetary nebulae in the thickened component add crisp emission line beacons, isolated red giants near the limit of resolution carry both distance and metallicity in their colors. Faint shells and fans, barely above the sky, whisper of accretions that salted the envelope without cracking the spine. Even after those structures smear into smoothness, abundance patterns refuse to forget, with alpha-rich, metal-poor cohorts floating higher than the iron-richer populations that cling to the razor's glow. Theory meets its examiner in the galactic rapier. Tweak the halo's shape and the warp's precession shifts, loosen feedback and the gas collapses into an implausibly sharp sheet, tighten it and the lane loses bite. Alter the bar and the box and peanut heart fattens or slumps, change the inflow history and the rim's stippled knots either vanish or overperform. Only a narrow corridor of ingredients reproduces the silhouette across wavelengths, the thickness of the midplane, the amplitude of corrugations, the breadth of the radio cocoon, the gentle lift of the ends, so the edge-on line doubles as a verdict on how galaxies self-regulate. Time domain adds punctuation to the celestial scalpel. Core-collapse supernovae pop along the pearled midplane, Type Ia events blink from older cohorts, novae pepper the thick disk, and X-ray binaries wink like small lighthouses above the seam. Most are footnotes in the grand narrative, but together they churn the gas, anneal the dust, and keep the fountain breathing, little weather systems that ensure the large-scale climate holds its balance. Project the Cetus blade forward and you see a long negotiation rather than a plot twist. The bar may buckle a little more and then relax. The inner ring will wax and wane with supply, bending waves will precess and fade, minor accretions will refresh the halo's memory, the rim will keep testing parcels for readiness. Unless a heavyweight interloper intrudes, the outline will change by degrees, not by rupture. Gas to clouds, clouds to clusters, clusters to metals and dust, dust back to clouds. The sentence continues, written edge-on, its calligraphy steady because so many quiet feedbacks agree on the same straight line.